Welcome. Today I'm going to talk about this new Bertech soldering mat that I bought for my workbench. So here is the before picture of my workbench. Now my workbench is made out of this countertop, like cheap kitchen countertop material that you can buy at your local hardware store. But I've never wanted to work directly on that, so I got these sheets of hardboard and put it on top, and that's been my work and soldering surface. So you can see there's burn marks here underneath the soldering iron where I do a lot of my soldering. There's other little burns here occasionally. There's gouges where I've worked on it and such. And this has worked out well for me, but it has started to curl here on the end. It doesn't kind of lay flat, it kind of pops up. And I've always had this seam in between the pieces where little bits of resistor lead and stuff will fall down into there. That's been annoying. And then the whole thing, it slips real easy. So you'll be working and you like move something and the whole surface, you can see it's all kind of slippery. So that is what I've been thinking I want to get away from with this new anti-static mat. It's just to get myself a nice work surface and also a work surface that is grounded. Because I do a lot of electronics and computer work on this. So I'm going to clean all this stuff off the workbench. I'm going to toss these old sheets of hardboard siding that I've been using, and we'll see how that turns out. This box has the new Bertech anti-static mat, so I'm going to take it out of the box and unroll it. It's actually quite heavy. There's two sides. There's a blue side that'll go up and a black side that'll go down. Okay, so I made a couple small mistakes while installing this. The first was where these cables go through this hole. What I should have done is just pulled this grommet up and made a super clean cut around the hole. Instead, I tried to cut around the exterior of the grommet and I made it kind of jagged and messed up. So I wish I'd have done that a little bit better. What I'll probably do is on my 3D printer, I'll probably just print one of these that's a little bit bigger. The worst mistake is what I had intended to do was to pull this up and then make a cut along the outside a little bit longer than the bench so that I could then lay it down and make that precise cut along the edge. But what I did is when I pulled it up, I thought I was cutting it straight, but I actually cut it at a little bit of an angle and cut into this part of it here. Which is kind of unfortunate. I realized that after I pulled it away, oops, I cut this crooked, so what I had to do is I had to come back and cut the whole thing in an inch to make it straight. Now what I think I could do is I could take a straight edge down here and I could recut this straight, and then I could cut a little sliver to go in there, then I could put some tape or something on the back of them, and then, you know, there might be a seam, but it would go all the way to the edge. I don't know if it's really that important for me to get it all the way to the edge over here. But I am, so far I'm pretty happy about the appearance of it. So you can kind of see it from end to end there. I'm pretty happy with the appearance of it. Let me put some stuff on it. Okay, I've set up a piece of the mat. You can see down here, I've set it up under my microscope. And we are currently viewing the picture on the microscope on the video monitor. So I kind of have my DSLR set up so it's pointing at a video screen. You see my hand there in front of the video screen. And then we are recording the microscope through that. So apologies if there's some artifacts present when we record off of the monitor like this. I still haven't quite got my setup perfected. But what I wanted to try now is let's try dripping some solder on this mat and see what happens. I've got my soldering iron here. Let's clean it off. Got my soldering iron. I've got some solder. The soldering iron is set for 370 degrees Fahrenheit. And we'll just get a blob of solder melted up and let it drip onto the mat. Well, here, a good shake will do it. There, so we've splattered some solder onto the mat. Now I'm going to let this cool down and we'll see what has happened to the mat. It's still liquidy. Oh, it's still a little bit liquidy. But it's getting cooled down. Takes solder a while to, there we go, there it's solidified up. So yeah, taking it off. This just, this might here just might be splatter from the flux. Yeah, that's just flux splatter. But I hope you can see the mat itself is not really deformed much, even with that hot solder sitting on there for a bit. I'm going to take and clean it up a little bit with some isopropyl alcohol. Still a little bit of flux residue on it. But what I wanted to kind of see here is if I do solder on this and if solder gets splattered on it, is it going to damage it? And it really doesn't look like it is. I don't really see any permanent damage to the mat. It has, maybe it's lost a little bit of its shininess in this area here, and you know, maybe I see a little bit of a rough spot there, but it really weathered through that in pretty good shape. Yeah, there you can get a kind of a look at it where you can see it discolored a little bit, but it didn't really burn a hole into it at all. I'm going to do one more so we can get maybe a little bit of a cleaner drip spot over here. This time I'm just going to naturally let it drip and splatter on its own. Amazing how a solder will stick on there for the longest time. There we go. And we will let it sit here and cool. So again, we dripped a little bit of flux on there and the solder itself. There, I would say it was cooled down. Solder just falls right off. The flux a little bit more stock. Let me still a little bit of flux sitting there perhaps. So once again, I think the soldering mat did pretty good with solder dripped on it. Really didn't damage it. It does, like I say, the surface color there is a little duller where the solder splattered on it, but it's not actually pitted or anything like that, which is pretty. So I'm going to take the soldering iron and I'm going to push in here with sort of medium pressure for about 5 seconds. Okay. So there we did make a tiny little pitted indentation. Certainly we did melt into the surface there. So inadvertently touching the soldering iron to the mat will damage it. I'm not really surprised at that. There, you can kind of see the little spot again right there. I mean, it's were it not under the microscope, you might not even notice that. I can't really see it with the naked eye that much, but you can certainly see it on the microscope. Just a little bit of burn through on the surface. Let's try giving it about 30 seconds, and I'm gonna try to put more sideways pressure on it. Give it about 30 seconds right here. Okay, there's 30 seconds. So again, we have done a little bit of damage to this sample with 30 seconds of exposure. But does it clean up? Yeah, it still cleans up pretty good. You can see it with the naked eye. And you can certainly see it under the microscope right there, so it's certainly damaged a little bit. I'm just curious, can I just burn a hole right through it by pushing? Pushing pretty hard on it. Yep. So yeah, you can punch a hole right through it. If you push hard enough on your soldering iron, certainly you can melt it, but to do that is actually, that's pretty abusive to it. And even at that, it hasn't really done a whole lot of damage to the surface. It's just a little divot there where the soldering iron got pushed through. So certainly using this as a soldering mat and dripping some solder on it doesn't really seem to hurt it very bad. Dripping flux on it doesn't seem to hurt it. Letting the soldering iron contact it will damage it, and certainly, you know, longer exposure and more pressure, you could eventually punch right through it. Now, just to see, you know, how does it react to something that isn't hot, like let's say this probe. If I was probing something and I just came along, push like so, am I hurting it? Not really. I think I left a little indentation, but I don't think I actually punctured it. I think that's just surface deformity. Let's try again. Right there. Yeah, it kind of pops back up in time, so certainly just poking around it. Oops. So certainly just sitting here poking around it with the probes, I'm not really gonna hurt it. It's pretty resilient to just plain ordinary mechanical stress. Bounces back. Something really sharp like these tweezers. Let me put something under it. Yeah, they put a little pinprick into it. But I don't think it pinpricked all the way through. Yeah, there, it certainly pinpricked through the first layer, but it does sort of self-repair back up pretty good. I don't see anything poking through the back of it. This here's that first hole that I burned through the soldering iron. It doesn't look like these are poking through it at all. So let's try again there. Yeah, I mean, it does leave a little mark, but it didn't go all the way through. So I think what I may do, since my tests on this sample prove that it is possible through abuse to do a little bit of damage to it, and since it does take a little bit of work to, when you get solder flux splattered, to clean it back off, what I might do is I might take, I have extra material, I might take and cut myself like a 1 foot by 1 foot piece, or maybe even 18 by 18, something like that, and then put it right under where I do most of my soldering under the microscope. That way when I'm soldering and when I'm doing a surface mount hot air rework, I would just have a disposable surface or an easy to clean surface, and if there was a mishap, I wouldn't damage the whole mat. And it'd also help with cleanup of stuff like solder flux, which does seem to take a little bit of scraping to get it back off the mat. Let's go over here and take a quick look at grounding. So I bought something here called a Desco Universal Snap. And what it is, it's a washer. It's kind of a conical washer that's threaded. There's a screw, and there's both a male and female snap option. And you puncture your mat, you screw it together, and that'll give you a snap mount. And then I bought some of these here, which are banana jack snaps. There's a male and a female side the banana jack can plug into. So if you pull this up, you can see here where I've got the bottom of the snap going through the bottom into the conductive side. Then you can pull this apart. It just snaps right off. It's nice and easy to remove this. If I wanted to remove the mat, I could. Could also just pull the banana jack out of this. Seems to be a professional way to install this. I did consider just putting a screw in a ring terminal, but it seemed like this did a little bit better job. And on the wire, I went in here, I put a couple of 1 meg resistors, so they're in parallel, so that's giving me about 500K of resistance. Seemed like a good amount, just because you want some resistance between the mat and your ground, just in case there's ever a wiring fault or something, I think. Anyway, this goes to a nice silicone wire, which runs down and hooks to a really good earth ground. Now let's talk a little bit about conductivity of the mat. I've got my fluke set up here, set to resistance, so we'll know if there's any conductivity. The top surface of these mats is supposed to be not conductive, and certainly I'm not seeing anything going on there on the top surface. Now if we flip the mat over, let's take a look at this scrap sample. The bottom surface is conductive, so right there, between these 2 points, something's going on. I can't get a good reading on it, but certainly there's some number of megohms of resistance across the bottom of the mat, just as there should be. And if I test from the bottom of my mat to a grounding point, because I have my grounding strap set up, let's see. There we will see about a megohm between the bottom of the mat and ground, so my mat is properly grounded. So that's working out great. So what do I think of this Bertech mat? Well, I'm happy with it. This is the first time I've ever used a soldering mat like this. I like the color of it. I think it has very high contrast. It's easy to see stuff. It actually does pick up dirt easily if you get dust or a flux residue or something on it, just because the blue is so glossy and high contrast, it does tend to show the dirt, but I think that's going to be the case of any mat. Its properties are as advertised. The bottom side is conductive, the top side is non-conductive, just like they said it's supposed to work, and I verified that that does work. One nice thing about it is it did not smell terrible. Sometimes you will buy a rubbery or plasticky thing from China and you'll get it and it'll smell toxic for weeks. I've had neoprene and rubber things that I've bought for the lab that you had to leave them out in the garage for a week before you could be in the same room with them. It was not at all the case with this mat. This mat was tolerable from the moment I enrolled it to be in the same room with it. Maybe it had a little bit of an odor I could detect, but really not bad. The durability, as I showed under the microscope here with the soldering iron, it seemed plenty durable to occasional mistakes like letting solder drip on it. Certainly intentional abuse will damage it, but that's going to be the case with any mat. So it was one of the more expensive mats. This was the Bertech Made in the USA mat. It cost like double their imported mat. Did I get a better product for buying the Made in the USA one? I think I did, but I don't have a sample of the other one, so I can't really directly compare them. But anyway, I do like it, I do recommend it, and I am happy I bought it. Thank you for watching my video. Please visit my website at www.smbaker.com for more electronics projects and sandrail stuff. Bye.